Let's look at it. A central angle is an angle whose vertex is the center of the circle. Now remember, if we just have a plain angle, and if we have the angle here at B is my vertex. So in order for a central angle to be given, this vertex has to be where? At the center. So the center will contain that vertex. So we actually have the two radii of AO and BO. So that forms a central angle right in here. And of course we have angle AOB. And that is its central, that is a central angle. Understand about central angles. There's two different angles. We can have a central angle or we can have an inscribed angle. Now an inscribed angle means that the vertex is on the circle. So this would be an inscribed angle. We have the following points on the circle. This would be angle CED. Here is our angle in this case. So in central angle, the vertex is on the circle. An inscribed angle is an angle whose vertex is on the circle. So the two different types of angles. Central is at the center, and inscribed is on the circle itself. Now, just a little tidbit. Here we talk about concentric circles. I know it's changing gears really quick, but something just to understand what that is. If we have concentric circles, those are circles that lie in the same plane and have the same center. Well, if I'm using this center here and I started drawing all these circles and I said, hey, they all have the same center, and they started going however big or however small. If all of these circles have the same center, we call them concentric circles. Prime example, a dartboard. I think some of you have already thought that in your head. That's what concentric circles is. Okay, a few more. What is an arc? Yes, an arc. Well, if we're looking here, an arc is a part of the circle itself. Meaning, if we're looking out here on the outer rim of the circle, it's the part of that circle. There are three types of circles. One is a semicircle. Well, a semicircle, since it's half of a circle, is described as being formed by a diameter. So we have to have the diameter, let's call that AC. We're going through center O. So the diameter forms the semicircle. Well, we have actually two semicircles. We have this semicircle here, and we have this one over here. So two semicircles in, or is half of a circle. Now, a minor arc. I'm going to erase that blue for a reason. What's the difference between a minor arc? A minor arc is smaller than a semicircle. Well, if a semicircle is half, then a minor arc would be here. We would have another line here, or rather, we could have a point if we wanted to. And this would be arc AB. Notice the notation above it now. We wanted to say arc AB. That notation means arc AB. We can also have arc BC. It too is a minor arc because it's less than a semicircle. A major arc is an arc greater than a semicircle, and we always use three letters. Three letters to describe a major arc. Have to have three letters. So if I'm looking here and I have the point D, then arc BCD. Arc BCD is a major arc. Notice that it is more than half of a semicircle. It's greater than, yes, 180 degrees. So notice the measure of a semicircle is 180 degrees. This is 180. A minor arc is less than 180, and so that means a major is more than 180. Equal, less than, greater than. Now, what do we know? The measure, notice it's capitalized, of an arc is the measure of its corresponding central angle. Corresponding central angle. So we have two different things that we can look at. Here I can look at the measure of the angle, or I can look at the measure of the arc. They will be the same. The measure of an arc, AB, so the measure of arc AB would be equal to the measure of its central angle. In this case, it's angle AOB. So really keep that in mind. Measure of angles, or measure of angles, are the same as the measure of their arcs. Just like we can have adjacent angles, we too can have adjacent arcs, such as arc AB and BC. They are adjacent because they share that common point. You can add the measures of adjacent arcs just like you can add the measures of adjacent angles. Thus, we have the arc addition postulate. The measure of the arc formed by two adjacent arcs is the sum of the measures of the two arcs. So here, if I have arc AB, is said to be 50 degrees, and I have here arc BC is said to be, let's say, 120 degrees. And I know that that's a little off scale, but we can work with it. What does it mean? I'm sorry about my notation. Well, the measure of arc A, B, C, rather, would be 50 plus 120. So the arc, or the measure of arc ABC, is 170. Now, three letters are used here just to show the difference. We know that a major arc gives us the three letters. So let's work another example of that. Let's get rid of all of this and show you how to use it with the exact three letters. All right, so we have arc AB, and we don't actually have to have our radii in here. We can just have the points. Arc AB is 100 degrees. Here we have point C, and let's say that arc BC is, I don't know, let's say 180 degrees. We want to know the measure of arc ABC. Just like segment addition, angle addition, we have arc addition. We add the two. So the measure of arc ABC would equal 100 plus 180 in this case, which is 280 degrees. Now, we can work this exactly the same way. What if by, say, some chance we were not told what BC was? We're saying, hey, find the measure of, we're looking for X over here, the measure of arc BC. Well, and if we're told the measure of arc ABC was this time 250 degrees, well, if the whole thing is 250 and we know part of it's 100, then 250 is equal to 100 plus X. Solving for X, we see that X, which is arc BC, equals, oops, sorry, of course it's X, would equal 150 degrees. All right, just a little refresher about circumference real quick. The circumference of a circle is the distance around the circle. Here we have the formula, circumference equals pi d, or circumference equals 2 pi r. Remember, we can use the approximation of pi as 3.14, or if you want to get really, really accurate, 22 divided by 7. Now, we talked about the measure of an arc in degrees. That's the measure of the arc, while the length of the arc is a fraction of the circle's circumference. So we have, say, arc AB here, and we're told that, hey, it's 90 degrees. What if I wanted to know the actual length of it? If I were able to put a piece of string here, what would the length of that arc actually be? And by doing so, we have what is called arc length. Now, so we have the final formula, arc length. The length of an arc of a circle is the product of the ratio, and this is our ratio, measure the arc divided by 360 and the circumference of the circle. Well, we have it here. So the length of an arc equals the measure in degrees of the arc divided by 360 times circumference. That's all this is right here. This is circumference. So we have a circle with a radius of 5, and arc AB is described. I'm going to get two things in here. All right, first of all, this central angle is 90 degrees. If this central angle of angle AOB is 90 degrees, what's the measure then of its arc in degrees? Remember, the central angle is the same, or the arc is the same as central angle, so this is 90 degrees. All right? Now, so let's find arc length. Well, arc length equals the measure of the arc divided by 360. Notice we're taking the part and we're dividing it by the whole because there's 360 degrees in a circle. Then we're going to multiply it times circumference. 2 pi times 5. Now, we can simply reduce this fraction if we so choose. What is that? 1/4 times 10 pi. We want to continue on. That's what? 10 over 4, which is 5/2 pi. Now, I realize a number like that you really cannot associate with. Let's go back. Let's think about it mathematically. We have 10 times 3.14 right here, essentially. And that gives us the circumference. So the original circumference is 31.4. Well, if we say 5 divided by 2, and we multiply that times 3.14, we get approximately 7.85. 7.85. How many times does 90 degrees go into 360? Well, 360 divided by 90 is 4. So if we take 31.4 and divide it by 4, right here, the circumference, divide it by 4, guess what we get? We get the arc length. So arc length is the fraction of the circle itself, of the circumference. So that's the reason why we take the measure and divide it by 360. It gives us that fraction part.